Hey guys, this is Coach Brian with your 1.1 pre-calculus notes, all about functions, specifically domain and range. So what we're going to be looking at is the different types of functions and how to find their domain and range. We'll be able to identify the type of function, its domain, its range, and any important points in that function. So first we need to reestablish some definitions. A lot of these things are going to be concepts that you learn in Algebra 2, like a function, which is a relationship, and it is between an input, which is your x value, and an output, which is your y. That's what you get out. You put an x in, you get a y out. A key for this is that each input only has one output. So for every x, there's only one y. Every x, there's only one y. Next, the vertical line test. This is a vertical line, and we can use it to test if a function or if a graph actually represents a function. And so the way it works is if any vertical line crosses a graph one or more times, so right there I wrote 1 plus 1 or more. Let me reword that. I'm just gonna write crosses a graph more than one. If it does that, if it crosses a graph more than one time, then it is not a function. All right, domain. Domain is the set of all possible inputs or x values. The range is the set of all possible outputs or y values. All right, is a line always a function? No, it's not. And I'm not going to explain to you why, because I want you to try to explain why or draw one that's not a function. But the answer is no. All right, let's work some examples now of putting these tests and this definition of a function to use. So first, determine if they are functions. I'm going to go ahead and tell you yes, no, no. So why is this first one a yes? Well, if we try the vertical line test on it, see how every single one of these lines only crosses one time? That means for every x, there's only one y. So it passes the vertical line test. Now, if we try the vertical line test for the second function, you can see one input right here has two outputs. Failed vertical line test. And then lastly, x equals y squared. When we use a function or when we're solving for y, we want to get our equation into y equals. So currently, the way it begins, we have x equals y squared, and that y could be isolated by finding the square root of both sides. So we have y equals the square root of x. And if I plug in, what's the square root of 0? 0. What's the square root of 1? Positive or negative 1. What's the square root of 4? Positive or negative 2. What's the square root of 9? Positive or negative 3. So I put in one number and I get out 2. So it fails definition of function. It is not one-to-one, as we would call it. All right. Still moving here. Inequality and interval notation. I'm going to start with an example. So for inequality notation, we could have something like x is greater than negative 2, but less than or equal to 4. So there's an example. I don't know why this select all keeps popping up. Now, this is inequality notation because inequalities are greater than, less than, greater than or equal to, less than or equal to. So you can see here, the x value falls somewhere between these numbers. Now, if we were making this a number line, it would look something like this. 1, 2, 3, 4. 1, 2. All right. So we've got 0, 1, 2, 3, 4, negative 1, negative 2. Okay. So since this is a greater than sign without the mark underneath it, we would put an open circle. And then since this is a less than or equal to, we would put a closed circle. And then all of the numbers that fall from this open circle to this closed circle are potential solutions. That's inequality notation. We would say that the 2 is excluded, and we would say that the 4 is included. And then for interval notation, I'm going to use the exact same numbers, use the exact same number line. We would say the interval is from negative 2 to 4 with a bracket. What does the parentheses mean? It means excluded. What does the bracket mean? It means included. So those are inequality and interval notation. Inequality and interval notation. One important thing about interval notation is you always put your low number on the left and your high number on the right. All right, let's look at another example. Example number 2. Determine if the relation below is a function. So to start off with, we would test it using the vertical line test. And I'm going to erase all these, so you may not want to draw them. But for every x value, 1, 2, 3, 4, 5, 6, 7, there is only one output. Oh, I don't know why I did that. There's only one output. Now, that passing of the vertical line test proves that this is a function. Now, the domain is all of the set of possible x values. So I'm going to sketch a little bit on here. Our first x value here is 1, and our last one is 7. And I want to point something out to you here. The 1 here is a closed dot, and the 7 over here, the 0, is an open dot. We would call this a hole in the graph. And if you look, there's one more over here. So the domain includes from 1 to 4 and from 4 to 7. And we need to write that in a way 1 to 4 and 4 to 7. And you might be asking, like, why wouldn't I go all the way 1 to 7? Well, we got a giant hole right here in the middle. So I need to find a way to write this correctly. So the first thing I'm going to start with is 1. It's a closed dot. So I'm going to put a bracket. And it goes all the way to 4, where there is an open dot. So I'm going to put a parentheses. And then I go from 4 again with that open dot, all right, 4. And I want to say I go to 7, but 7 is open. So I'm going to go to the last value that has an actual output. So we'll put 6. And then since these domains are connected, I'm going to put a union. Now for our range, we're going to use the similar concept. I'm going to draw a horizontal line at our lowest point and a horizontal line at our highest point. That's going to be our range. And so for this, the lowest point way down here is solid, and the highest point way up here is also solid. So they are going to be included. So again, I want to start with the low number. The lowest number over here is -1. The highest number over here, we can estimate, we'll say 2.5. And they're both closed in, so they're both included. I'm going to let you try B and C, and we're going to jump down to the bottom of the page. Now, some function notation. Remember, our inputs are our x's. Our outputs are what you get when you plug x into the function. So I plug in my x into the function and something pops out. And we generally call this a y. And so we can say that y equals f of x. And if you look over here, f of x equaling y represents xy. And this is exactly true. If we're saying these two things are equal, we're saying that I put in the x into my function and I get something out. If you put that onto a graph, it would be your x and your y. Let's try a few more examples using actual functions. So this looks a lot more like something you'll see in class soon. We have a function here, f of x, and it is x squared minus 3x plus 5. So it asks us to first find the value of the function when x is 2. When our input is 2. So what that means is everywhere there's an x, here, mean, even here when you're writing it, you're going to put in a 2. So we would say function with an input of 2 equals 2 squared minus 3 times 2 plus 5. And now it says, what's the value of f? So we need to actually solve this. So 2 squared is 4. 3 times 2 is 6 plus 5. So we've got 4 minus 6 plus 5. 4 minus 6 plus 5 equals 3. There's my solution. Now, this next one, A, is my input. I don't know what A is, but that's okay. I can go as far as it will allow me. You know, I'll go as far as the knowledge I have. So I'm going to replace every x, 1, 2, 3, with a's. So function with a as the input equals a squared minus 3 times a plus 5. And that's as far as I can go without actually knowing what a is. Now, this last one. Function of x minus 2. Everywhere there's an x, I'm going to replace it with x minus 2. Now I've got that plugged in, so I need to follow the order of operations. Now, this is where all that math knowledge from your past few years is going to. You're going to need all of it, okay? So the first thing is, this is a binomial. So when you're squaring a binomial, you do not just distribute. Do not do that. Do not just distribute. You have to double distribute, or what your teacher might have called FOIL, or maybe you use the box method in Algebra 2. There's a lot of different ways that you can do it. Because I know that a lot of Algebra 2 teachers have used the box method, we can do that now, just for visual sake. X minus 2 times x minus 2. So x times x is x squared minus 2x plus 4. So write that out. It is x squared minus 4x plus 4. So that's this part squared. Okay? Next, this section, this is going to be distribution. So negative 3 times x. I'm going to write this in a different color just so they kind of stand out. Negative 3 times x is negative 3x. Negative 3 times the negative 2, negative times a negative, is a positive. And then the very last thing here on the end, plus 5. Now, all of these things are, I worked out all of this stuff so far. Now I need to combine like terms. So I need to combine all the things that have an x squared, all the things that have just an x, and all the things that are whole numbers. So what I'm going to do is I'm going to start with the x squareds. They're only these guys right here. So I'm going to put x squared. Then I'm going to look at everything that has an x attached to it. So look, I've got a negative 4 and a negative 3. Negative plus a negative is more negative. So negative 4 plus negative 3 makes me more negative. And then lastly, I'm going to combine all of the things that have just a constant, or just a number with no variable attached. 6 plus 4 plus 5. 6 plus 4 is 10, plus 5 is 15. And that is my final answer. All right. I'm not going to do all of this next one in its entirety. I'm just going to show you some examples. These are my inputs. These are my two functions. So if I put in -2 to function f, I get out -7. If I put in a -2 to function g, I get out a 10. So what it's asking me to do is like read this chart essentially, because all the answers are in here. So find function f where 3 is the input. So what I'm going to do is go over here to my column of inputs, and I'm going to go, okay, there's 3. Here's function f. When I put 3 into function f, I get -2. Now, the next one that I'm going to do, you've also got this one over here, so don't forget it. But the next one I'm going to show you is just one of the more, not really complex, but just one of the harder ones. So right here, it says find t, okay, if f of t is -5. So what it's now asking me to do is find the input. I'm trying to find which one in this column for function f gives me -5. So I'm going to go look in the f column and see how I've got -5 right here as an output. What input gave me that output? And the answer is 0. So t equals 0 if f of t equals -5. All right, we're getting close to the end. I know this is a long note, so I'm trying to move quick. This next section, example 3, is just some graphing practice. So it says graph each point with its associated label. If you look, this is the input, which is the x. What it equals is the output. Because remember earlier we said f of x equals y. Input equals the output. So what this is saying is if I put in a 2, I get out a 6. And if you remember, let me make that look a little cleaner. If you remember, we said that that is an XY pair. So when you put in a 2, you get out a 6, you would go graph that. I go 1, 2, 1, 2, 3, 4, 5, 6. That is the point A. Mark it with the letter A. I'll let you do B and C. All right, example number 4. If you've taken physics or are taking it right now, this will look really familiar to you in a couple months, maybe weeks. All right, the height of a baseball, t seconds after it is hit, can be modeled by this function. So think about it, the height. So that's what this is. The time, that's what all the t's are. So what it's asking us to do is find the height 3 seconds after this ball has been hit. 3 seconds after. So if this is our input, that means everywhere there's a t, we're going to replace it with a 3. So function h with an input of 3 seconds equals -16 times 3 squared. It's important to see that that squared and the t go together, not to the 16, but to the time, plus 64 times 3 plus 2. All right, I'm doing all this with no calculator, so let's work it out. 3 squared is 9. Negative 16 times 9. That's my first number right there. And then I'm going to add 64 times 3. Well, 3 times 6 is 18, so that's 180 plus 12. That's 192 plus 2. So I've still got a little bit more. I'm following my order of operations here. I've still got a little more before I can combine these terms. I need to do negative 16 times 9. So 16 times 9, that's 90 and 54. That's going to be negative 144 plus 192 plus 12. Now I can combine these. And if you see, we've got a big negative number that we're about to add a big positive number to. And those are probably going to kind of neutralize each other. So if I take negative 144 and I add positive 192, that leaves me with a difference of 48. And then I've got to add 12. So 48 plus 12. 48 plus 12. If I did that right, let me just double check. 192 minus 144. That's going to give me 8. 8 minus 4 is 4. 1 minus 1 is 0. 48, yeah. So I got 48 and I got 12, and together that is 60. And let me see if they give me a unit. They did not, so I'm just going to leave it as 60. If they told you it was feet, if they told you it was meters, whatever, you would want to put that. And now it says, what does that actually mean? Explain the meaning of H3. That means 3 seconds, actually, after being hit, the ball is 60. I don't know what it is, so I'm just going to put units in the air. Now, almost done. Finding domain. These are 2 times that you will really want to look for trouble. Look for trouble. Because there's some like math rules that these could be breaking. This first one, a fraction. I'm sure you remember this, or as soon as I say it, it will ring a bell. But the denominator of a fraction cannot equal 0. It absolutely cannot equal 0. So if you were trying to look for trouble, you would say, this denominator, what will make this 0? So isolate it. X plus 3 equals 0. Okay. Minus 3. Minus 3. When x equals negative 3, that will be 0. So what did we just say? It can't equal 0. So the reason you find out what makes it equal 0 is because this answer is not allowed. Now you would ask yourself, did any other numbers make it 0? No. So if every other possible number except negative 3 works, how would you write that? And we would write it like negative infinity all the way up to negative 3, but not including negative 3 because it's not allowed. And then from negative 3 all the way to infinity. All those are good, but you know what's not good? Negative 3. Cannot be negative 3. Now, one last little note here. You use parentheses for infinity, okay? Use parentheses for infinity. Why? Well, can you ever actually include infinity? Once you think you include it, there's one more number, and then there's one more number, and then there's one more number. So you can never include infinity. That's why we always use parentheses. Now, on this side, if y'all don't remember, this is a radical, and this guy that I'm highlighting in green right here, all right, that's our radical symbol. What's underneath it is called our radicand. And it has a rule also. The radicand must absolutely be 0 or higher. It can't be negative, because if you remember that really confusing concept from Algebra 2 called imaginary numbers, cannot be negative. It has to be 0, because square root of 0 is 0, or something higher, something positive. So you would say, what makes this break the rule? What makes this less than 0? And so what you would do is you would take your x plus 3. You can say, I have to keep it greater than or equal to 0. It can't be below 0. And then when you solve this, you would just move this guy over. And so you'd say, okay, x has to be greater than or equal to negative 3. How can we write that as a interval? Well, you would say the low end is negative 3. And there's a little mark right there, so it's included. And then from there, it just goes up infinitely. So it goes from negative 3 to infinity. Thank you for enduring these long 1.1 notes. I finally got it filmed on my 4th try. Hopefully they help you.